Welcome to Chapter 8 of Class 8 Science, Nature of Matter, Elements, Compounds, and Mixtures. In this fascinating chapter, we'll explore how all matter around us can be classified into three main categories: elements, compounds, and mixtures. We begin by observing everyday examples: the food we eat, the air we breathe, the water we drink, and learn to classify them based on their composition and properties. Get ready to discover why stainless steel is considered a mixture, how water can be broken down into hydrogen and oxygen, and what makes compounds so different from the elements that form them. Let's begin by understanding mixtures. Mixtures are formed when two or more substances are combined without any chemical reaction occurring between them. The key characteristic of mixtures is that each component retains its individual properties. We encounter mixtures everywhere in daily life, from the poha and sprout salad we eat to the sugar dissolved in our drinks. Mixtures can be uniform, where the components are evenly distributed and not visible separately, like sugar in water or air. Or they can be non-uniform, where we can see the different components, like in a salad or sand in water. A special type of mixture is alloys, uniform mixtures of metals like stainless steel, brass, and bronze. Interestingly, ancient Indian texts mention the medicinal use of alloys like mishraloha, showing advanced metallurgical knowledge thousands of years ago. Now let's investigate whether air is a mixture. Air is indeed a uniform mixture of mainly nitrogen, oxygen, argon, carbon dioxide, and water vapor. In Activity 8.1, we test for carbon dioxide in air using lime water. When calcium hydroxide solution, lime water, is exposed to air, it turns milky due to the formation of calcium carbonate, confirming the presence of carbon dioxide. In Activity 8.2, we place a black sheet of paper near a window and observe dust particles settling on it, showing that air contains suspended particulate matter. These dust particles are not part of air's natural composition but are pollutants. The Air Quality Index helps us monitor these pollutants and understand air quality in different areas. Now let's understand pure substances. The word pure has different meanings in common usage and science. In everyday language, pure means unadulterated, not mixed with cheaper substances. But in science, a pure substance has no other substances present in it and consists of the same type of particles throughout. For example, while we might call milk pure in common language, scientifically it's a mixture of water, fats, proteins, and other substances. Pure substances are classified into two types: elements and compounds. Elements are the simplest substances that cannot be broken down further, while compounds are formed when elements combine chemically. Understanding this distinction is fundamental to chemistry. Let's explore elements, the building blocks of all matter. Elements are substances that cannot be broken down into simpler substances by chemical reactions. Each element is made up of identical particles called atoms. In Activity 8.3, we pass electricity through water and observe that it breaks down into hydrogen and oxygen gases. Hydrogen burns with a pop sound, while oxygen makes a flame glow brighter. This shows that water is not an element but composed of hydrogen and oxygen elements. Elements are classified as metals like gold, iron, non-metals like oxygen, carbon, and metalloids like silicon. Most elements are solids at room temperature, only 11 are gases, and just 2 are liquids: mercury, metal, and bromine, non-metal. Now let's understand compounds. Compounds are formed when different elements combine chemically in fixed ratios. The properties of compounds are completely different from their constituent elements. For example, water is a compound of hydrogen and oxygen, but it has none of the properties of either gas. In Activity 8.4, we heat sugar and observe that it decomposes into carbon and water, showing that sugar is a compound of carbon, hydrogen, and oxygen. Common salt is another compound, formed from sodium, a soft, reactive metal, and chlorine, a toxic gas, but the compound is harmless and essential for life. Compounds cannot be separated into their elements by physical methods. They require chemical reactions or energy input like electricity. Let's perform a comprehensive experiment comparing mixtures and compounds using iron and sulfur. In Activity 8.5, we create sample A by mixing iron filings and sulfur powder. This is a mixture where both components retain their properties. Iron is magnetic and can be separated using a magnet. When we heat this mixture, it forms sample B, iron sulfide, which is a compound with completely different properties. The compound is not magnetic, has uniform appearance, and reacts with acid to produce hydrogen sulfide gas, with rotten egg smell instead of hydrogen gas. This experiment clearly demonstrates the key differences between mixtures and compounds. Mixtures retain component properties and can be separated physically, while compounds have new properties and cannot be separated physically. Now let's explore the real-world applications of elements, compounds, and mixtures. Understanding these concepts drives innovation in many fields. Air mixture is essential for breathing, water compound is essential for life, and elements like iron and aluminum are used in construction. Material scientists have developed wonder materials like graphene aerogel, the lightest material on Earth made from carbon, which can potentially clean oil spills. Minerals are natural substances found in Earth's crust. Most are compounds, but some like gold and silver are native elements. Traditional Indian arts like Dokra use metal alloys to create beautiful artifacts, showing practical applications of metal mixtures. This knowledge helps us develop new materials, medicines, and technologies that improve our lives. As we conclude this chapter, let's review the key concepts and their importance. We've learned to classify matter into elements, simplest substances, compounds, chemically combined elements with new properties, and mixtures, physically combined substances retaining individual properties. We've conducted experiments to distinguish between these categories and understood their real-world applications. This classification system forms the foundation of chemistry and helps us understand everything from the air we breathe to the materials we use daily. Remember that most things around us are mixtures, while pure elements and compounds are less common in everyday life. This knowledge not only helps us understand our world better but also enables scientific innovation that improves our quality of life.